So, when it comes to the properties of a pure substance and what saturation means, what superheated means, or what compressed liquid means, it's important to really be able to get a good grasp of that. So, when you're talking about a compressed liquid, that basically just means the liquid phase of a substance. Some of you have probably heard of liquid nitrogen, right? That's what happens when you compress nitrogen gas to the point where it actually condenses. And so, as you can see here, we can achieve a liquid phase at a higher temperature, but we do that through compression, and it'll be on one of these higher isobaric contours. The saturated phase is the boiling phase. At this point, it is energy saturated, and so you're waiting for this latent phase, which is why it's called latent heat of vaporization, or at least the energy required per unit of fluid to change. The reason we call it a latent phase is because it causes a delay in the increase in temperature. Notice it is flat along the temperature dimension. And saturated means that you can keep putting in more and more input, such as heat, but it just won't change a particular condition. And so these contours show that we have a saturation temperature. Think of saturation like putting sugar or salt into water. You can mix it up, you can warm the water up to make it more absorbent. That's like going up from one contour to the next. But ultimately, you reach a point where you keep adding and it just doesn't stay. That sugar or salt doesn't dissolve, at which point you have a saturated solution. In our case, we are adding energy. We add more and more and more, but we're still stuck in here. So we are energy saturated. But the superheated vapor stage is what happens when the liquid phase in here finally swallows up enough energy to boil. And that's what causes the delay. It's that phase change. So superheated phase is pure gaseous phase of the material. So it behaves just like a liquid phase does. Given the pressure, it just behaves like a normal, typical phase. You add heat, temperature goes up. Take heat out, temperature goes down. Now, when it comes to saturated phases, we have a property called percent quality. And that's the percentage of gas in the mixture. So something closer to the left here will have more compressed liquid. We could tell because the specific volume is smaller. Remember, liquids are dense, gases are diffuse. So as we move along this contour, this section of the contour here, the saturated phase, we gain specific volume because it's boiling from liquid and turning into a gas. So down here, our X value is lower, and over here, our percent quality goes up. It's also important to understand why pure substances can technically be a mixture of different compounds together in one solution. This is an example of an impure substance, and the purity of a substance really, in this case, refers to the consistency of its behavior. Instead, you see an interruption here in the middle before reaching the boiling point of water. The alcohol boils first and turns to a gas. Then the water heats up like normal. Once again, you have a flat temperature domain because of that latent effect. The latent heat of vaporization of the alcohol means the alcohol molecules are swallowing up all the energy, changing phases from liquid to gas. Once that's done, energy can continue to go into warming of the water until that boils, and then now you have a gaseous mixture. So it's important to understand that a pure substance can technically have multiple compounds, but it will have one of these phase changes, not two of them.